this percent problem stuff. A lot of people like to see these in equations. So they'd say, look, if you got a percent, you take a percent, you multiply it by the whole value or the total, however much you have, and then it equals that value, right? So let's say this is a whole, and then this is a part. The problem is not that we don't know which is the whole and which is the part. The problem is that sometimes we don't know whether we need to multiply or divide. So if we stick with fishy method on this, then we should be golden, okay? Now if we do that though, it sets up like this. It's still a proportion. And that's what I like about this, is if we just learn about proportions, if we stick with proportions, then we should be good. So it's always going to be out of 100, because it's a percent, right? And then we put the percent, it's out of 100. So hopefully that makes sense at least. But then the percent always represents a part of the whole, I don't know, all of it. Even if that percent is more than 100%, okay? So you can have more parts than a whole, right? Now, keywords we're looking for here is the part is usually the is value, the is number. The whole is the of value. Now, I just tell my students to focus on this of stuff, but some people like the is stuff, okay? What this means is that if we see of and then the number that comes after that, that is where that whole value will be. If we see the word is, then the value that comes after that word is the part. And that's where they go. So sometimes the percent will be missing, and then we use fishy method to solve for it. Sometimes the part is missing, and again, fishy method, the whole, doesn't matter where it is, it's always the same, okay? So we don't have to worry about if we're multiplying, dividing, how to solve an equation here, it's just fishy method. Context. Setting up this proportion, it's always going to be out of 100. They gave us the percent, so that's an easy one. That goes over the 100. Now, there's two things on this. So we have the is word right there. Is 54, and that's the part. But they also told us it's of what number? And of is the whole, and that value goes in the denominator of that second fraction. So that's the unknown. From here, we just use fishy method. So that would be 54 times 100 divided by 30. And when I put that into the calculator, I typed that in wrong. So when we solve this one, we see that the number that we wanted is 180. I'll set my proportion up out of 100. And again, it gives us the percent at 40. And then it shows us that it's of 8. So again, there's that keyword of. Of 8 needs to go in the denominator. And our unknown now is in the numerator. So to solve this one, we would have 8 times 40 divided by 100. And that would be our unknown, right? That's it. There's our fish right there. So 8 times 40 divided by 100. Bam, 3.2. There it is. Number 6 will set up the same way out of 100, but this one did not give us the percent, so that's going to be where our unknown is. And then it shows it's of 80, so that's going to be in the denominator. And then the $30 just has nowhere else to go but the numerator there. So we can use fish method, 100 times 30 divided by 80. And what does that give us?
37.5.
Thank you. 37.5. Now this one was a percent, so we should label it 37.5%. So we can see the rest of these, I mean, they're worded differently, but the process is always the same. It just depends on where the unknown goes. So number one, right, the unknown was the whole value in the denominator. Number two, the unknown was in the numerator because it was the part. And then 6 had the percent, which was unknown. All right, so we'll set up our proportion. It's out of 100. They gave us a percent, 3.6. And it's of the 72, so that'll be our denominator. And we don't know what that part value is. So we'll set this up, 72 times the 3.6 times 100 should equal our unknown, the part.
Wouldn't it be divided by 100?
Oh, dang it. One of those days. Thank you. But yes, it is definitely divide. So 72, sorry.
No, I was gonna say, I'm just a negative on my test every year.
You know, today I would probably do the same thing several times. This is what I got, 2.592